Okay, so the topic that we are interested in this project is photo dissociation regions, PDR. That's where the PDRs4all name comes from. And so photo dissociation regions are the result of UV interaction from massive stars with the interstellar medium. And the Orion bar, which you see here in a multi-wavelength image, is the prototypical photo dissociation region where you have massive stars of the trapezium, which are not seen in the image but are somewhere around here, which illuminate a slab of interstellar medium. And this region here in blue is fully ionized and is at a high kinetic temperature of around 10,000 K. And at the ionization front, hydrogen recombines with electrons and becomes neutral, and you have this region where basically hydrogen is fully neutral, and the temperature drops to some 1000 K. And when you go deeper into the cloud, the hydrogen atoms can recombine and form H2 at the dissociation front, which you see here. And eventually, if you go even deeper in the cloud, you go to regions where the gas is fully molecular and the temperature is around 30 K. So if you look at an infrared spectrum from these type of regions, this is what you will see basically with the James Webb. So it's a very rich spectrum where you have in the near spec range here from 1 to 5 microns a lot of lines which are due to molecular hydrogen vibrational emission. And you have also these bands that you also find at longer wavelengths, which are called the aromatic infrared bands, and which are commonly attributed to the infrared emission of stochastically heated molecules or small grains of this type of the family of polycyclic aromatic hydrocarbon PAHs. So many of the spectra that you will see with JWST, including in galaxies, especially in starburst galaxies, will come from PDRs and look like this. You will see molecular hydrogen lines and aromatic infrared band emission in many cases. So for this reason also, for understanding a distant object, it's also important to look in detail at regions such as the Orion Nebula, which is close by because it's only 400 parsecs, to interpret JWST spectra. So the observations we have is, of course, near-infrared and mid-infrared spectroscopy with MIRI and near-spec in integral field unit modes. But we also have NIRCam observations, which is the topic of today. And these NIRCam observations are really made to get a global picture of the region and of the physical structure of the nebula, of the PDR at a larger scale, because the fields of view of the spectroscopy are very small. More precisely, if you look at the Orion bar at visible wavelength here, this is a visible image obtained with the Hubble Space Telescope, and you zoom into this small region here, you find again here this three-color background image as in the previous image, and here you see the fields of view of the MIRI and the near-spec IFU spectroscopic mosaics that we will obtain as a cut across the PDR in this region. So it's very small fields of view, and for the imaging we will obtain much larger fields of view which cover basically most of the bar. The trapezium stars are there, so we try to avoid them to avoid saturation. But you see here, for instance, there is a bright star which we need to evaluate with the simulations whether it will saturate the detectors or not. And the MIRI observations in imaging are here. They are relatively small, and this is because we need to use the subarray in MIRI to avoid saturation in the mid-infrared, because the bar is very strong. Mid-infrared source, it's about as strong as in a specific intensity as Jupiter. Okay, so this is just a small note that in addition to the physical structure of the cloud, in this region we will also observe two protoplanetary disks, irradiated protoplanetary disks, which are found inside the Orion bar. The scientific objectives of the project are multiple, so I will not go through all the details. Basically, there is one part which is really dedicated to understanding the microphysics of photodissociation regions and constraining the existing models. There are a number of models of PDRs which are widely used, and we wish to constrain these models with these new observations. There is also an important aspect of the project which is concerning carbonaceous species. So molecule and grains related to pH molecules, polycyclic aromatic hydrocarbons. And so the goal is to understand their evolution and their role in the chemical and physical structure of these photodissociation regions. Finally, the last item, which I quickly mentioned earlier, is we would like to provide a sort of toolbox to help people interpret distant PDRs or spatially unresolved PDRs, where you will not see this stratified structure that I showed in the previous images. Everything will be in a single pixel in a way. So with just the spectra, you will need some tools to interpret this PDR emission that will be seen in many environments, and we wish to provide such tools as part of the project. So in terms of products, we have two types of products in the projects that will be available on the website, and some of them are already in fact available on our website. We have what we call the data products. So this is just the data itself, but in a refined version. For instance, the MIRI cubes we will provide, we hope that we will be able to stitch the cubes. That means that all the orders of the MIRI integral field unit spectroscopy will be stitched together. The NIRCam images will be fully calibrated and mosaics, and we hope to cross-calibrate them with the spectroscopy. The NIRSpec cubes will also be given in a fully reduced format, and same applies to the MIRI images, and also we wish to cross-calibrate these MIRI images. One challenge will also be to remove and avoid possible saturation issues, because, as I said, we are observing a very bright source. We are also expected to deliver a number of science-enabling products, which are tools and products that are needed to support the interpretation of JWST data. We have already provided some simulated data that you can obtain through our website, so NIRSpec IFU simulations of the Orion bar and synthetic spectra of the Orion bar. We will provide what we call enhanced data products, which correspond to these data products I have mentioned here, but even in a more reduced forms. So things such as the maps of specific features, for instance, a map in a specific H2 line, and some template spectra extracted from the key regions in the photodissociation region of the Orion bar. And we have tools which are dedicated to the data reduction and processing, which are listed here. I will not go through the details of this list. And finally, we have what we call data interpretation tools, which are tools basically connected to some form of modeling behind that from the data will allow you to extract some physical conditions from the data. So that's all I wanted to say about the project. If you want more details, we have this paper that is just out last May with all the details on the program, all technicals and observational details. You can go and have a look at this paper.